Sparse coding, how the brain compresses massive information. How the brain represents complex input using fewer active neurons. Why the brain cannot process everything fully. At any moment, the brain receives more information than it can process in detail. Visual scenes, sounds, and internal signals all arrive at once. If every neuron responded to every detail, the system would become inefficient and overwhelmed. Instead, the brain uses strategies to reduce the amount of activity needed to represent information. One of these strategies is known as sparse coding. What sparse coding means? Sparse coding refers to a way of representing information where only a small number of neurons are active at any given time. Rather than spreading activity across many neurons, the brain selects a limited set that best represents the input. Each active neuron carries meaningful information, while most neurons remain inactive. This creates a more efficient system for processing and storing data. How the brain selects active neurons. When sensory input arrives, the brain evaluates which features are most important. Neurons that respond strongly to those features become active, while others remain silent. This selection process is influenced by prior experience and learned patterns. Over time, the brain becomes better at identifying the most informative elements of input. This allows it to represent complex information using fewer signals. The role of experience in shaping representations. Sparse coding is not fixed. It adapts based on experience. As the brain encounters similar patterns repeatedly, it refines how it represents them. Neurons become specialized for certain features, such as edges in vision or specific sounds in hearing. This specialization improves efficiency because the brain does not need to relearn patterns each time. Instead, it uses existing representations. Why sparse coding improves efficiency? By activating fewer neurons, the brain reduces energy use. Neural activity requires metabolic resources, so limiting activity helps conserve energy. Sparse coding also reduces redundancy, meaning the same information is not represented multiple times unnecessarily. This makes processing faster and more efficient. It allows the brain to handle large amounts of information without becoming overloaded. Applications in sensory systems. Sparse coding is especially important in sensory systems. In vision, for example, neurons respond to specific features such as edges or orientations. Instead of representing every pixel, the brain focuses on meaningful patterns. This allows it to interpret complex scenes quickly. Similar principles apply to hearing and other sensory modalities where the brain extracts key features from input. The balance between sparsity and accuracy. While sparse coding improves efficiency, it must be balanced with accuracy. If too few neurons are active, important details may be lost. If too many are active, efficiency decreases. The brain adjusts this balance dynamically depending on the situation. This flexibility allows it to maintain both efficiency and precision. How sparse coding relates to memory. Sparse representations also play a role in memory. By storing information in a compressed form, the brain can manage large amounts of data more effectively. Sparse coding reduces overlap between different memories, which helps prevent interference. This makes it easier to retrieve specific information when needed. Insights for artificial intelligence. The concept of sparse coding has influenced artificial intelligence and machine learning. Algorithms inspired by this principle aim to represent data efficiently by focusing on key features. This approach improves performance in tasks such as image recognition and data compression. Studying the brain's methods provides valuable insights for designing more efficient systems. Final thoughts. Sparse coding shows how the brain manages complexity by reducing the amount of activity needed to represent information. By activating only a small number of neurons, it creates efficient and meaningful representations of the world. This strategy allows the brain to process large amounts of input while conserving energy and maintaining accuracy. Understanding sparse coding provides deeper insight into how the brain handles information in an efficient and adaptive way. Thanks for watching.